lecture of Computer Integrated Manufacturing in Automobile Industry. I am Milan Trivedi, Assistant Professor at LJIET Institute of Engineering and Technology. So in the last class, we had already started with the chapter number 3, that is Group Technology and CAPP. In that, we had already understood that what is a group technology. Group technology is actually a method of grouping a similar object into a part families, right? And according to that particular part family, we are defining a machine cells, right? In that machine cell, we will be having a different machining units, right? So in how to actually define the particular part family, for that we are having a specific techniques. The one technique was actually the coding technique. In that we were actually discussing about the hybrid code system. OPTIZ system is one of the coding system which is widely used in the industrial practice, right? The OPTIZ code system will be in these 3 segments. The first segment will be having a 5 digits which is called as a form code. It is followed with the 4 digits which is called as a supplementary code, and lastly it is followed with the 4 alphabeticals which is called as a secondary code. What do we mean by the form code is that form code actually gives the idea about the part geometry and features which is relevant to the part design. The supplementary code gives the information which is relevant to the manufacturing type, and the secondary code gives the production processes and the production sequence, right? So what actually happening is, as per my earlier lecture also I had given you the example that from your enrollment number itself we can get the idea that which batch student you are, in which branch you had taken the admission, and in which college of GT you had taken the admission. So in similar way, from this particular code itself you will get the idea about the part geometry, the manufacturing process, its sequence, all the data you will get. Now still let us go in detail about the form code. As I told, form code is having this 5 digits. This first digit is actually defining you about the part class, right? From the part class you will be having this kind of values. Say for example, if the part is having a L by D ratio less than 0.5, if some company has made this, then they will write 0 over this, right? If the L by D ratio is between 0.5 and 3, then they will write 1 for that. Same way, second digit is actually defining the external shape and the different elements of the external shape, right? Say for example, the shape is smooth, no shape, and then it will be defined as a 0, right? Same way, if 3 is there, then it may be 2, 3, similar way. So all this particular digit will be defining certain parameters of the particular part. In the third digit is actually for the internal shape and the internal shape elements, right? For that we are having this different sequences. Fourth digit is actually defining the plane surface machining, right? Whatever machining you are doing on the plane part, that is, as per that we are having the different digits, right? If you write this 6 over the fourth digit, then actually it means internal plane surface or slot, right? So we can get the data in this way. The fifth digit on form code actually means the particular gear teeth system, right? Next one is a supplementary code. Form code is actually followed with the supplementary code, in which we are having a 4 digits. The sixth digit is indicating the dimensions of the object directly. Seventh digit is indicating the material which you are using. In this particularly it is like that. Say for example, one number is given to iron. So if 7 digit you are writing as 1, then the particular person who is just looking to the part, he will get to know that this component is made up of iron, right? If second is for, if 2 number is given for copper, so if 7 digit 2 is mentioned, then we can come to know that it is a copper material, right? So this is how the code has been read. Eighth digit is actually giving the idea about the original shape of the raw material, and ninth digit is defining that at what kind of accuracy is required in the case of particular part, right? Now let us understand the concept of the cellular manufacturing. Cellular manufacturing, as we had already discussed, that in group technology we are actually making a different machine cells, right, as per the different part families, right? So in each and every cells we are having a dissimilar machines. So cellular manufacturing is nothing but it is an application of group technology in which dissimilar machines or processes are aggregated into a cells. and each of which is dedicated to the production of part family or limited group of families. Now, the different objectives which has been solved with the help of this formation of machine cell, this one cell is called as actually the cellular manufacturing concept. But this formation of cellular manufacturing concept shortens the manufacturing lead time and the material handling time. It reduces the work in progress. It improves the quality of the product, and it simplifies the production scheduling and the process planning. And lastly, it reduces the different setup times. So on an average, the prime objective is to actually enhance the productivity by just reducing the manufacturing lead time. No doubt the initial exercise is large, but once we do this particular group technology concept, then later on we can actually reduce the time. So these are the different types of machine cells. If in one particular area if we are keeping only one machine, then it is called as a single machine, right? If we are having a group of machine cells, but there is a manual handling, if persons are being deployed just to transfer the machine from one machine cell to the another machine, then it is called as a group machine cell with manual handling. And the third one is a flow line cell, in which the material is being transferred from one machine to the another with the help of automation, maybe a conveyors or some chain belt drives which has been driven automatically with the help of different drives, right? If such technology has been used, then it is called as a flow line cells. Now the advantages of entire this group technology concept is the standardization of tools, fixtures and setups are encouraged. The material handling is being reduced. Parts are moved within a machine cell rather than the entire factory area, right? So as there are limited machining operations are required for one part, that part is actually required to travel across only one machine cell instead of traveling across the entire factory. Then the process planning and production scheduling will get very simplified. The next advantage is the work in process and the manufacturing lead time will be reduced, and there will be an improve in the work satisfaction to the workers which is working in the group technology, and that actually can lead to the higher quality work. Now let us understand the concept of computer aided process planning, right? The process planning is actually nothing but it is a deciding of the sequence of operation, that which machining operation is required first, which requires second, looking towards the part, right? But some of the times you can take the help of the computer, then it is called as a computer aided process planning. There are basically three techniques in the case of computer aided process planning, right? You are given one particular code, right? And the code details will be fed to the particular computer. So what will happen is, if you are mentioning the code, then that will identify that it belongs to which particular part family. Machine will identify that. It will decide from the library of the particular manufacturing machine cell that which operations are which machines are required later on that particular machine, which kind of operations are required to be performed, and according to that it will form the particular process plan. This is called as a variant type or retrieval type of process plan. It is called as a retrieval because we are just retrieving the data from the code itself. These are the things which you had given input to the computer at the primary stage itself. Just what the computer is doing, it is just reading the particular code, and according to that it is generating a process plan. The second one is a generative type of process plan, in which we not only can retrieve the data from the particular computer, but along with that we can have our logical decisions in between, right? If some editing is required in between, we can make that, then it is called as a generative type, right? So user is actually giving the input as a code to the controller, it will generate a plan for that, right? But say for example, if some of the part is requiring a better machining surface, right? So according to that we are actually giving some addition process parameters, and they will generate a plan that is called as a generative type of CAPP. And last one is a hybrid type, which is actually a combination of variant and generative. That's all for the today's lecture.